Welcome to TOC class. Here in this class, I discuss about language acceptance of DFA and introduction about NFA. This is the definition for language acceptance. If you take a string X and if X is accepted by a finite automata, that means generally DFA is called as finite automata. So wherever finite automata is available, defaultly it mentioned as DFA. So that finite automata is M. I say that one, and only if, that is, the string X is accepted by finite automata only if which condition means the transition function tilde of Q0X is equal to P. What does P means? P is the state in final state. So we already know the definition of finite automata. It is a quintuple representation. That means set of states, set of input symbols, transition function, starting state and final state. So if you give a correct input string to the finite automata, then the transition function go to the several states, several set of states Q, and if the last input string of a correct notation of X is accepted means then that will go to accept state. That is the definition of this language acceptance. So now I give the example for this one. So this is the possible DFA. Okay. So this is the DFA state in which, suppose I give the example for the string is 0 1 0 1 0. So you check it out directly from the diagram, 0 1 0 1 0. So it is accepted, which means what? This DFA starts with a 0 and end with a 0. Okay. So how can we check whether the given X, that means the string is accepted by this finite automata? So now I take the starting state of this DFA, that is Q0. I want to check the input string X. So X contains the input string 0 1 0. Now you refer the transition flow of Q0 0 from the diagram. So if Q0 0 means it goes to Q1 state. So I write that particular state in the first parameter. So now I am in Q1 state. I already visited 0. The remaining strings are 1 0 1 0. Now you refer Q1 1 in the diagram. Q1 1 means the same state is there. So tilde of Q1 comma, I already visited 1. So the remaining strings are 0 1 0. Now you refer Q1 0. So Q1 0 means it goes to Q2. So tilde of Q2, the remaining strings are 1 0. So you check tilde of Q2. So Q2 1 means it goes to Q1 state. So Q1 remaining string is 0. Now you refer Q1 0. Q1 0 means I got an input as Q2. So what is the final state of this given finite automata? It is Q2. So after checking all the input strings by applying the transition flow, I reach the state as Q2, where Q2 is the final state. So this is the language acceptance of finite automata. Okay. Then next concept is NFA. So this is one of the another type of finite automata. What is the main difference between DFA and NFA means? DFA which contains only one output state. But in NFA, there may be the possibility of more than one output state. For example, this is the DFA diagram. Only one outflow is there for every input symbol. So this is the DFA. For NFA diagram, I draw it as, so for 0 input, there may be the possibility of more than one output state. So this is the difference between NFA and DFA. So what are the parameters available in DFA is also applicable to NFA. So NFA is also a quintuple representation which contains these 5 parameters in it. Only difference is the input representation. So here the alphabet symbols, the empty string is also be considered as an alphabet symbol for transition flow. So if you are using epsilon as an input symbol for finite automata, then that particular NFA is called as epsilon NFA. We'll discuss this concept in next class. Okay. So if you go for a non-deterministic finite automata, the transition function receives, there may be the possibility of more than one state or an input string. Okay. Now, the same problem. What are all the problems discussed in DFA? The sample problems are noted out here. The first problem is all string ending with 0, 1. So, the first step is you should write the correct strings. So, first string is 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1. Like that the strings will be go. So you take the first string, it contains 2 letters. So what is the possibility? There may be the possibility of 3 states. So the same notations which is available in a DFA is also applicable for NFA. So Q0 to Q1 with the symbol 0, Q1 to Q2 with the symbol 1. Then ending. So it is ending with 0, 1. So what is the remaining options? So it's ending with 0, 1. The remaining symbols may be 0 or 1. So first symbol after completion of 0, 1, what are the remaining symbol means either the combinations only 0, 0, 1 or 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1 like that. So this is the notations. So if you refer Q0, for Q0, tilde of Q0, 0, there may be the possibility of 2 output states. One is Q0 and another one is Q1. So if you draw the transition table for the given finite automata, you get an answer like this. So Q0, the input symbols are 0, 1. So Q0, 0, Q0, 1. Q0, 1 means Q0. Q1, 0, there is no possibility. Q1, 1 means Q2 and Q2 is a final state. So if you refer the tabular column, in the first column, first row, first column, there may be the possibility of more than one output state. So the given finite automata is NFA. Okay. Then the second problem, all string with substring 0, 1. So this should have a substring 0, 1, 0. So how many possible states are there? 3 length means there may be the possibility of 4 states. So you first draw it 0, 1, 0. So there is no intermediate symbols from 0, 1, 0. Substring means either this may be an intermediate string or it may be a prefix of a string or it may be a suffix of a string. Okay, so the possibility is the self loop of first or last. Prefix may be 0 or 1, suffix may be 0 or 1. So now you refer it. Then the next problem, all string in which the third symbol from right. So third symbol from right, I don't know the number, so I just only draw Q. So this is the first symbol, this is the final state. So first symbol, second symbol, this is the third symbol. So third symbol from the right should always be A. So you should take an alphabet as AB. So third symbol from right is A. What is the last symbol? Last symbol may be A or B. Last second symbol may be A or B. But last third symbol should be A. The remaining symbols may be A or B. So this is, so you specify the states. So this is the NFA. Then all strings starts with 0, end with 1. So I am not writing the possible strings. So all strings starts with 0 and end with 1. So starts with 0, end with 1. Intermediate values may be 0 or 1. So this is a NFA diagram. And all string at least 3B. So 3 B's means there may be the possibility of 4 states. So these are all 4 states and condition is for B. 3b, at least 3b. Then the remaining symbols may be either A or B, this one A or B, this one A or B, and this one A or B, because minimum 3B. So I draw minimum 3B, maximum n number of B's are there. So in every self loop I put A and B. So exactly 3B means it's related to DFA because there is a specific condition. So you cannot put B as a self loop in all these 4 states. So the diagram of this NFA state is same as DFA state. So this is the basic difference between DFA and NFA. So now you are aware of the difference between those two symbols. So each symbol causes only one move. In an NFA there may be the possibility of more than one move. So if you take transition flow, only one output state is there. Here there may be the possibility of 2 power q states. That means if you take number of states are 2 means the possible output states may be 2 power 2 4. For example, q0 0. So only q0 q1 states are available means you can able to write it as 4 values. Like that the difference between DFA and NFA will be discussed. Then why we are preferring NFA? So compared to the sentences which is available in both DFA and NFA, we may able to analyze that the drawing of NFA is easy. So why we are not preferring DFA means the conversion of regular expression. Regular expression means a symbol, that is, which has some notations in it. For every sentence we can able to write it as a generalized form. The generalized form with specific notations is called as regular expression. So the conversion of that regular expression to DFA is a complex one, and for storing the states is a it will take more memory for storing the states in DFA, and also in DFA state it is not possible to move to the next state without reading any symbol in it. So that only NFA will be preferred more. So construction of NFA is easy. Then if you want to need a DFA means we should go for a conversion of NFA to DFA. So this conversion and the theorem and the problematic portions of NFA and DFA will be discussed in next class. Thank you.